Okay, ladies and gentlemen, so we're looking at 3.3, properties of slopes and lines. Really quick, we've done this before in grade 9. A line with a positive slope goes up left to right. A line with a negative slope falls down left to right. So what does that mean? That means if I have a Cartesian plane, remember that's named after someone. That's named after Rene Descartes. That's why it's called a Cartesian plane. And so if I have a line that goes like this, okay, you'll notice that if I go to do the right triangle with it, I have a positive run and I have a positive rise. That's a positive over a positive. That gives you a positive slope. Now, what I want you to understand is we could pick a point and we could choose to go this way and down. Notice I've always been going to the right and up or to the right and down. You could go to the left and down. So from this point to this point, that would be a negative run, and that would be a negative rise, which would give you a negative over a negative. But we know that a negative divided by a negative works out to be a positive in the end. So it doesn't matter which way you go. I prefer to go to the right and either up or down. That's my preference, but it doesn't matter. And that's important to know. Now, a negative slope, well, that's going to be a line that's going to fall left to right. So that's a line that would look something like this. So as I go left to right, as I go from the left-hand side of the graph to the right-hand side of the graph, so moving left to right, I'm going to go over and down. That is a negative slope. And notice that when I do that, my run is positive, but my rise is negative, which gives me a slope of rise over run of negative over a positive, which is a negative. That's how that works out. Okay, a horizontal line. Well, a horizontal line is a flat line, is what this is saying. And okay, I can live with that. A horizontal line is sometimes called flat, and it has a slope of 0. So a horizontal line, I'm going to look for a piece of paper here. Here I have one. Hey, I got this up in the way. Can you guys see what I was doing with that in the way? You guys okay? All right. So a horizontal line has a slope of 0. Now let's think of what that means if you're a horizontal line. If you're a horizontal line, and we talk about rise and run, look at this. You've got lots and lots and lots of run, but you have absolutely no rise, right? So when you're looking at the slope of a horizontal line, you're thinking of rise over run. You've got 0 rise, but you've got lots of run. There's lots and lots of run. So 0 divided by any number is 0. So that's a horizontal line. Now let's think about that in contrast with a vertical line. If I have a vertical line, now let's think about that in terms of rise over run. I don't have very much run in between these 2 points, do I? In fact, there's no run at all. I don't move left and right. There's absolutely no run. But there could be a whole bunch of rise, couldn't there? So this is that case that we talked about where we have a number divided by 0. The answer's not 0. We talked about this in class. So this is an interesting case that we say undefined slope. Okay, it's not 0, it's not 1, it's not error, as your calculator sometimes says. It is undefined. So a vertical line has undefined slope. And sometimes what we'll see is we'll say that could represent a vertical slope, 1 over 0. But that's not really a number. And for a horizontal slope, we would say 0 over 1, or just simply 0. Parallel lines have the same slope. So what does that mean to be a parallel line in a Cartesian plane? We've talked about parallel lines in triangles, but a parallel line in a Cartesian plane means two things that look like that. And what's really happening here is this triangle is the same as this triangle. Okay? And what that means is the slopes are equal. The slopes will be the same for both those. Now, what is different? The y-intercept, right? The y-intercept's big time different. This one is a positive y-intercept. This one's a negative y-intercept. So let me give you a slope of this let's pretend it's 3 over 2. Let's pretend rise over run. Let's pretend I go over 2, I go up 3. Let's pretend I go over 2, I go up 3. Let's make sure you guys know what I'm talking about. If I go over 4, how high should I go up then? How many? If it's over 2, up 3, if that's our slope, if I go over 4, I should go up 6. That's right. Okay. And if I'm down here, and if I go over, let's say I go over 6, how high should I go up? So if I go over 6 here, I should go up 9 here. Now notice that all of these slopes are the same. The slope of 3 over 2, 6 over 4, and 9 over 6 are all the same slope. How come? Let's think about this for a minute. 3 over 2, now 6 over 4 is 3 times 2 over 2 times 2. Do you agree that 3 times 2 is 6 and 4 times 4, or 2 times 2 is 4? So if we reduce those, do you see how we're left with just a 3 over 2? And let's think about the 9 over 6. Well, the 9 over 6 could be 3 times 3, and the 6 can be 2 times 3. Do you see how there's a 3 and a 3 here? And that leaves us a 3 over 2. This is called reducing. And it's because these are similar triangles again. The ratios are the same. Now, so I told you that this has a slope of 3 over 2. If they're parallel, then this has a slope of 3 over 2. Let's pretend that this is the number 5. Let's pretend that this is negative 7. So we now can come up with the equations. The equation of the top one will be y equals 3 over 2x plus 5, because its y-intercept is plus 5. And this one would be y equals 3 over 2x minus 7. Do you see the difference between them? This one plus 5, this one minus 7, but the slopes are the same. There you go. So parallel lines have same slope. What else do we know? Ignoring the sign of the coefficient of x, the greater the coefficient of x, the steeper the line. So when you look at these two lines, and someone says which one is steeper, what we do is we forget about the sign, because that doesn't tell us anything about steepness, positive or negative. That tells us if it goes up or down. What we look at is this number. The larger the number, the steeper it is. Okay? So the larger the slope, the steeper it's going to be. And let's think about why that might be the case. If I have a Cartesian plane, and I have a point, and if I move over 1 and up 2, so the over 1, up 2, there's my line. That's a slope of 2 over 1. Now let's think about a slope of 5 over 1. That would be over 1, up 5. See how much steeper that is? Over 1, up 5 in this case. So that's a much steeper line. So the higher the value of the slope, the steeper the line. Okay, so positive slopes look like uphill slopes going left to right. Negative slopes are downhill slopes going left to right. Horizontal have slope of 0. vertical, have an undefined slope. You need to know those. Okay, example 1. Determine the slope of each object. So, what we're going to do is we're going to use slope equals rise over run. Taking a look at this, there's my 90, this is my rise, this is my run. So, what I'm going to do is I'm going to put in the numbers, 50 over 100. This is going to have a slope of 1/2. Notice it's positive because if I was going from this point to this point, it would be positive run and positive rise, which gives us a positive slope. Notice that the run is twice the rise. You can see that here. For every 1 unit we go up, we go 2 units that way. Or another way to say this, for every 2 units we go this way, we go 1 unit up. Because this is our rise and this is our run. All right, let's look at the next one. So I have a set of stairs here. We want to determine the slope. This is 32. See that indication there? That's called inches. That's the short form for inches. So that's 32 inches high. And this is 42 inches out. So if we need to calculate the slope, it's going to be rise over run. So the rise is 32 inches. The run is 48 inches. Now, something we should probably talk about. Look over here. Did you see what I did? I don't know if I explained it. In fact, I know I didn't. See how this is 50 over 100? And it became 1 over 2. Do you know how I did that? I just reduced, right? There's 150 in 50, but there's 2 50s in 100. So this really was 50 times 1 over 50 times 2, and I reduced it to 1/2. You always want to put your slopes into lowest terms. So now I've got 32 and 48. What are the lowest terms that can be reduced to? Well, if you know your times tables really well, it's easy. If you don't, then I have a trick for you. But if you know your times tables, then you know that 32 will divide by 8, and it goes in 4 times. You also know that 48 will divide by 8, and it goes in 6 times. So I can go even more than that. Maybe I can do 12. 32 will divide by 12. No. So 32, well, let's do it slow. I found 8 to work, but you know what? What's the lowest number? What's a really easy number that we know will go into 32 and 48 at the same time? 2. So we can do this in steps, right? We can do 32 divided by 2, which is 16, and can do 48 divided by 2. 48 divided by 2. And that'll give us 24. And then we can do that again, right? We can use our calculators and do that again. So now it's going to be 8 over 12. And then we can do that again if we want, and we can get 4 over 6. And then we can do it one more time, and we can get 2 over 3. And I don't care if you can do it all in one shot. Some of your calculators can do it all in one shot, but I certainly don't want the decimal. 0.6 doesn't mean a lot when we're talking about slope, does it? But this does. This means for every unit I go this way, for every 3 units I go this way, I go up 2 units. That's what this says, which is the same as going over 48 and up 32. Okay, let's take a look at the next example. I'll pause the video for a moment and we'll be right back.